Okay, I've given you an assignment and you're all in even space, no? And then, so we will discuss the assignment today. The assignment is about programming. No? The
Yes, sir.
yes. Question.
Send po ako ng email sa assignment ko po, sir, ba kay na late ako nagpasa po, sir, ba di na gilak ng ang ano, sir, ang submission po.
Sige, anyway, I'll get the email, no? But next time around, I will not accept email, no? But this time I will accept, no, for newcomers. No problem, okay? I'll check the email, okay?
Ako din, sir. Scratch ang napas ko, sir.
Sino yan? Sino ito?
Sir, ako din po, sir.
Scratch ako napasa, sir.
Can you text me? Can you chat? So I'm not confused.
Ako din, na-receive yung email ko, sir.
Yeah, I haven't read emails yet. I had a class since this morning.
Okay po, okay po. Ako din po, sir.
Pasa ako, scratch.
I'll check the email, no? Okay. And then, yeah. So, nandito na tayo. Okay. This is about I will only discuss a part of the assignment. No, I will not discuss the Fahrenheit to centigrade anymore. Okay, because this very simple. No, this is a programming assignment for the PDP this is a new assignment. No, the programming assignment for the PDP-1, which we will discuss anyway today. No? Okay, what was our problem then? That was the third assignment already. Where was that? IAS. No? IAS programs. No? We are okay. The IAS programming exercise on was that? Let me check. Anyway, it's in my file, no? Let me check. IAS programming, because we had a loop factorial before, no? Now we are going to discuss the sum and average. Okay. IAS, where's that? Sum and average. It's here. Anyway, no? There's also an IAS program for Fahrenheit to centigrade, which I'm not going to discuss anymore. It's self-explanatory. I'm only going to discuss the sum and average of three numbers. Okay. Now I have posted this already. You can look at this, no, at our regular site. No? The solution is posted there. Okay. Where's that? Can I show you the solution? It's here, no? Sum and average, no? Sum and average with loop for the IAS. You can download this. I have just uploaded this early this morning. No? Tanduyan email, IAS. Okay. Third assignment is, this is the second assignment that I'm going to discuss, no? And then the third assignment I'm going to discuss later, okay? The third assignment is due on Monday next week. By the way, I was informed earlier by my students who are members of the Samahan that Tuesday may be part of the college. Is that a college week? College fiesta. Thursday.
Excuse me, sir.
Yes.
May call time po kami for palaro, sir. So I am from CS1B, sir, Cardemark. And then
What is that?
may game po kami 3 p.m. Tapos ang call time po 2:30.
I think the whole day will be declared no classes, no? I was informed that it might be declared, it will be declared. They're just waiting for the formal memo from the...
Okay, sir.
So you just wait for my email. I think I will declare no classes na lang. Siguro because it's there are student activities. And I'm informed by a Samahan officer, okay? But it's rather informal, so I cannot declare it yet. No? Who just came in? Ranyas and Anyo. Anyway, they're here. No? So I'll just email you anyway. No, if there's no class, if I'm not online, it means we will not have no classes. We'll have no classes. Okay, you follow? Kasi I think the email will be late. The memo will be late. So this is the sum of the first three numbers. Okay, for the IAS. This is the same program which I've shown you in the factorial. Do you follow? The factorial example which I've shown you. Okay, the main difference, however, is that instead of computing the partial product, we will compute the partial sum. Do you follow? So having to compute sum, we will have to change our multiplication into addition. Do you follow? So ito. Now, we'll have the same assignment of variables, no? M1, which used to be the partial product, will now be the partial sum. Anyway, it's the same. Our increment is here in M2, and M3 will be our next addend. Okay, this is not our next multiplier. Do you follow? But it's the same thing. We just have to change the multiplication to addition. So this is the same, no? This is the same. The main problem here is when we compute for the partial sum here, no? Okay, do you follow? Instead of mul M1, we will have add M1. Do you follow? Okay. So this is a top-down loop because we have our condition here. Okay, let me erase this so that we can trace everything from scratch. Hindi ko lang i-erase yung mga, no. I will not erase the headers, okay? Be careful not to erase the headers. I've repeated the headers myself so that we can easily track them, okay? So we have the same thing, no? So instead of the partial sum, the product, we have the partial sum, and this will be our next addend here. So we have to jump 4, no? L. Later, I'll show you a program without a left and a right, no? From a different machine. So we have load negative of M1. Any questions, no? We'll start now. I think, have we recorded? Yes, no? Load absolute of M1. So the absolute of M1 is the negative, no? Negative of the absolute of M1. So AC will have -3 because it will force negative. Okay. Add M2. M2 is 1. So the contents will be -3 plus 1. So this will become a 2. And we store M3. So whatever the value is, this is 2. No? Do you follow? And we store it to no, this is -2. I'm sorry, no? Okay. So we will store this to -2 to M3. Do you follow? Do you follow? And we jump plus. Currently, we don't do a jump. We will not execute this jump. Why? Because the AC is negative. Jump plus will not execute if the AC is negative. Okay? We have discussed this already. So we will not jump plus. We will go to load this. The next is load absolute of M3. Okay? So AC will have the absolute value of M3, which is 2. And then we have to add M1. M1 is currently 3. Ito, no? We have to pull this a little. Okay. So this is M1, no? So this will become 2 plus 3. They follow. So this becomes 5. Okay. And then store M1. So this is our next partial sum. This becomes 5. Okay. We now have computed the partial sum. We compute the next addend. Okay. Okay, they follow. Load M3. M3 is -2, so this becomes -2. We add M2, so this becomes -2 plus 1. So this becomes -1. Okay, and then we jump back to the start. Jump back to the start because there's no condition. Okay, so we go back. So AC is -1. M1 is 5. M2 is 1, and what's our M3? M3 is -2. Okay. We follow, we go to the second pass. Okay. We go to the second pass. So we store M3. So this becomes -1. M3 because AC is -1. We don't do a jump plus because AC is negative. we load positive of, rather absolute of M3. So M3, this becomes 1. We add M1, so this becomes 5 plus 1. We follow, this becomes 6. Then we store it here as the answer. So 6, this becomes 6. And then we compute the next addend, okay? Load M3, so this becomes negative 1. And then we add M2, so this becomes negative 1 plus 1. Do you follow? So this is 1 minus 1. Okay? So this becomes a 0. Do you follow? And then we jump to 5019. Okay? Balik tayo sa taas. There's no other choice because we have no condition. AC is 0. M1 is 6. This is a 1. What's our M3? It's a negative 1. But at the top, we store M3, so this becomes 0. Do you follow? AC is, this is now positive, jump plus. So therefore, we will skip to 9L. Okay, which gives our last answer, which is 6. Do you follow? So it's exactly almost the same. Okay. Do you follow? So this is now uploaded in our Dagler site. So we have the sum of the first 3 numbers to be 6, which is correct. So any questions?
Sir, may question ako, sir.
Yes, Aaron.
Paano malaman yung last na halt, sir, kung ano yung final na answer? For example, pwede i-scroll down, sir.
Yes. Our final answer is M1.
M1 palagi yung i-register ng program?
Not necessarily. You can use any variable. Just like in any programming language, you can assign it to any variable. In fact, in our previous examples, we have used the partial product to be M3, di ba?
Ay, pero paano malaman yung last na jump, sir, kung ano yung answer?
You just specify, no, that the final answer will be an M1.
Ay, so di na kailangan na i-program sa mismong...
If you want, you can set it back to AC before you do here. Okay, you can set it back to AC, but it's not required, no. You follow?
Yes, sir.
Anyway, as long as the logic is correct, no, because in other programming languages, you can use any variable, okay, to store your final answer. So in this case here, you can also use any value in the column, in the memory. Okay?
Pero okay lang din, sir, na nasa AC lang siya. Diba?
Oh, yes, of course, no. If you want to transfer it to the AC, you can always have a load here before you will have your halt in 9R, and then you will have a load M1. Okay? You will have a load M1 so that your final answer will be in the AC. Because in this case, the AC is already 0. Do you follow? 0 na siya, so you have to recopy it before you halt. Okay? Any other questions? Okay. It's all right to put it in the AC, but I don't require it anymore. It's already correct. It's of use, no? But it's you're free, no? Anyway, the next problem is to compute the average. What's the difference between the average and sum? Well, your final answer, you divide it with the total number of addends, right? Okay, the sum divided by the total number of addends equals the average, right? But our problem is in the sum, we don't have the total number of addends anymore because we previously put it to M6 and M1 and M3. They're all gone, both gone at the end. So we cannot use M1 to be the divisor because 6 divided by 6 equals 1, which is wrong. We also cannot use M3 because it's already 0. Do you follow? So what we do at the start, we will store the final divisor in one of the memory addresses, right? That's the only thing, so that we can save it and then we leave it unharmed or unchanged there, and we can retrieve it in the final step to be our final divisor. Since we have inserted it here at the 4, we will now start with 5L. Do you get my point? This is wrong, so this should be jump 5. No, sorry, I'll have to update. I'm sorry, I have to update. This is because there's a mistake. Anyway, this is an unchanged mistake. No, baka na I have discussed this properly in my in my other classes. Okay, where's that? The fourth factorial will have the sum and the average. Then edit. Okay. Just edit this so that I won't forget. Anyway, I think we'll have time, no? IAS sum and average. Okay. So it's there. No? So we'll have to jump left. Hindi na 4L. 4 will take 40 bits. So therefore, wala tayong magawa. We'll have to start with 5L. Okay? We load M1 because this is our, and then we store it to M4. This is just a temporary variable. So that this will be left unchanged. Okay? And then we repeat the same process. We load negative of M1. So that's, this is negative 3. Okay? And then we store, we add 1. So this is negative 2. This will be our next addend. And then this we start with our head. This is our head, no? And then we jump plus. We don't do a jump plus because it's still negative 2. Then anyway, this will repeat, right? Okay, but now we will jump to 12, which no, dapat hindi 12, no? This should be 11. Okay, this should be 11. I'm sorry, no? Should be 11, no? Because we will not terminate right away. Do you follow? We should not terminate right away, but we should divide it first. We should divide the final result first, no? Where is that? Ito, no? Okay. Let me just edit this first. One more time. I'm not going to trace this anymore, no? As long as we reach 0, when we reach 0, this jump plus will terminate, and we will jump to 11L. Do you follow? And in 11L, we are going to load M1. So this is now, tama ba ito? 3 plus 2, yes. In the end, this will become 6, right? This will become 6 in the end. Dito, this will become 6. Okay, and then since we will load M1, this will become 6. The accumulator will become 6. And then we will divide it with M4. So this will become 6 divided by 3. Do you follow? So the final answer is in the accumulator. Do you follow? May kulang pa pala tayo, no? Dapat i-store natin. Let me store it in insert. This is 12L. We will store M1. They follow? 6 divided by 3 is 2, by the way. So this becomes 2. Okay. So this will become 12R. 12R. Sorry, na. So this becomes 20 to 39. 20 to 39. It's R. Where did we jump? 11. Is this still correct? Yes, no? Kasi dito sa 11R. Store M1 so that we can have the final value also in, okay? So I have to update this one more time. Any questions so far? Any questions? Because I'm going to introduce a new machine, okay?
Sir, may ask ako, sir.
Yes.
If yung kanina, sir, yung sa average, if dalawang pass ko, sir, ba? So, mali siya.
Come again.
Like, dalawa ang pass ko, sir, ba, sa average?
Yes, of course. Dalawa talaga. Do you follow? Dalawa talaga. Sa akin, isa lang because I did not trace it anymore. Do you follow? Diba? Dapat dalawa naman talaga, di ba? Dalawa talaga. But I did not introduce the second pass anymore. I just assumed, no, that you already have the no. Okay?
Okay, sir. Thank you, sir.
Okay. So anyway, no? So, dalawang pass talaga. Actually, dalawang pass talaga yan. Okay? I'm sorry, no? I shortcut, no? I assume that this is the value in the end. Okay? Do you follow? In the end, ito na yung, I skip the second pass because it's the same. Anyway, no? Pareho lang naman sila. So, I don't have to go through the same because it's a waste of time, no? I'm sorry, no? I have to upload this first. Where's that, no? Excuse me for a while. Where's the assignment? Sum and average is called sum and average. This. Very slight, no. Anyway, it's a very slight correction. Okay. So the two passes should be, no, is correct. Okay. The two passes is correct. Okay. I didn't go through the second pass anymore. Anyway, I would like to show you, no, a different machine which was invented in 1959. Okay, and was released in 1960. Remember that the IAS was released in 1952. Do you follow? So about 7 years later. You may ask, what happened to the computers in between? They are almost, no, they're just almost the same as the IAS. No, the significant improvement came in 1959 from a company called DEC, Digital Electronics Corporation. It's a competitor of IBM. Because right after the IAS was produced in 1952, by 1953, IBM also manufactured and sold their first stored program computer. IBM already at that time was a tech giant. So they were able to produce quickly. And they were also, no, in collaboration with Harvard. No, that's why they were able to quickly develop their own version of the stored program concept. So anyway, they're the same. So the important part is the PDP-1, which came in 1960. Okay. What's unique of PDP-1? Okay, 1960 ito, no? Well, it's a smaller machine. Do you follow? And the important feature of PDP-1, we will see later, is that the size of data and the size of instruction is the same. Remember that in the IAS, data is 40 bits and instruction is 20 bits. Do you follow? Do you follow? Data is 40 bits and instruction. So we will have a left and right instructions. Now, for the PDP-1, they have made it smaller. It's only an 18-bit computer. Okay? Being 18 bits, it will have 18 bits for data and also 18 bits for instruction. 12-bit operands and 8-bit opcodes, no? So 20, no, 12, sorry, 8-bit operands and 10-bit opcodes. No, 8 plus, sorry, 8-bit operands, 8-bit opcodes and 10-bit operands. No? Kasi ang opcode is 8. Okay? You can have a lot, no? So it can have a maximum of 65536 bytes, no? And 4096 words, where one word is 18 bits. Okay, so 18 times 4096 is that 65536? I'm not sure, no? No. So 18 bits. It's like the IAS 4096 words, no? 4K, but this time it's not 40 bits. It's only 18 bits. The good thing about the PDP-1 is the size of data and the size of instruction is the same. Now there are other features, no? The PDP-1 had a precision CRT display. This is the very first computer with a cathode ray tube, no? Let's look at the PDP-1. So if you're asked, what is the first computer with a monitor? It's the PDP-1, no? Ito. This is the PDP-1, okay? You follow? By DEC, released in 1960. Okay? It has a magnetic tape transport, no? It has a so it is tape. It can now save the tape. So instead of just punch cards, so punch cards are becoming obsolete by this time. Okay, and then it has a typewriter keyboard. So it has a keyboard using a typewriter. I didn't know how they convert this into electronic signals, but this is the very first computer with the circular CRT tube. Okay, and then a typewriter as the keyboard. Do you follow? So imagine, no, you have a computer like that. It must have been a very noisy computer because it's a typewriter. It uses a typewriter as a keyboard. But it's very popular, okay? It sold about more than the first IBM, sold about 50 copies. No? Do you follow? So the number system is fixed point with 18 bits. By the way, it's enough, no? So with 18 bits, you have nine whole numbers, and you'll have 9 binary places or decimal places. It's okay. But anyway, during multiplication, it will take the multiplier quotient. It has a multiplier quotient register. It does indirect register addressing. We'll discuss this later. It uses the content of the register to address memory, not the register itself. Okay. So what I'd like you to look at is the set of instructions. This is the handbook. So, for example, in the IAS, you have add m of y. Do you follow? In the PDP-1, you will have add y. Okay? The m is omitted, but it's the same. The contents of AC are the sum of the contents of y plus the original contents of AC. Okay? So it's just a different vocabulary. Now, in the IAS, you will have sum m of add sub m of y. Do you follow? In the PDP-1, you will have sub y. Okay? Do you follow? You have mul y. This is slightly different, but for whole numbers, they're the same. No? Mul y. In the IAS, you will have mul m of y. You'll have div y, instead of div m of y. Okay, it has logical operations, It has shift operations, Now, ito, general instructions, load and store. In the IAS, you will have load m of y. Do you follow? In the PDP-1, you have LACY. LAC means load accumulator. Okay? So they just change the language anyway, But it has the same purpose. Okay, now this is important, for the IAS, you will have store m of y. Right? The accumulator is stored to the memory y. Now here you have DAC A of y, DAC, deposit accumulator. Okay, so that's the most different. That's the most different command because it's no longer store, but it's really DAC, deposit accumulator. Okay, there are many others, and then I'd like to look at the jump, In the IAS, it's jump m of y, In the PDP-1, you'll say jump y. Okay. There are many others. I'd like you to look at the skip. Okay. The skip. This is the conditional jumps. Okay. Now, this has a lot of group skip operations. In this computer, there's no longer an issue of the structure of loop that you're going to adopt because it can do both top down and bottom up. Okay, in fact, it has an equivalent of CF and jump plus at the same time. Skip on zero accumulator. This will just skip. It will skip only one line. Okay, skip if the accumulator is 0. Okay, skip if the accumulator is plus. Okay, so this includes, this is like the jump plus. Do you follow? The skip on 0 is like the CF. Okay, and the skip on plus accumulator is like the jump plus. So it has both. So therefore, you can do both top down and bottom up. Okay,
Hey sir, may question ako.
Yes.
Itong plus accumulator, sir, mag-jump lang siya if positive yung nasa...
If it's not negative, no? If it's positive or zero.
Okay.
You follow?
Then like opposite siya kapag minus accumulator.
Yes, opposite kung minus accumulator, which means it's really negative. Zero overflow if there's no during a device division there's no remainder, no? Or in during an addition or subtraction there's no overflow on the last bit. We will discuss overflows in the future, no? Okay. So the most important thing is it has both the equivalent of CF and jump plus. So we don't have a problem of looping. Do you follow? No? Okay, any questions so far? Now, let me show you the equivalent of the factorial program on the PDP-1. Okay. So, you'll find it much simpler. Okay. So, this is the same of the, I translated this from the IAS. No? So, this is a bottom-up loop. Bottom-up loop, but yes, the condition is at the bottom. Do you follow? Okay. So anyway, the logic is the same, right? The logic in fact, the micro instructions are the same except at the last. Okay. These are repetition of partial product and next multiplier. Okay. Likewise, no, our partial product is n of 1, our decrement is n of 2, and our next multiplier is m of 3. Okay. So we say load m of 1. Do you follow? No. In the IAS, we say load m of 1. Here we say LAC 1. Okay. So the accumulator becomes 4. Okay. Do you follow? And then we say in the IAS we say sub m of 2. Here we say sub 2. So which means that we will have 4 minus 1. So this becomes 3. The accumulator becomes 3. Okay. When we say DAC, deposit accumulator 3. So it's just like store m of 3. So this becomes 3. The micro instructions are the same. Do you follow? Okay, and then we load accumulator LAC1. So load m of 1, this is 4. And then we mul 3. 4 times 3, this becomes 12. We DAC 1, which means the deposit. The DAC D means deposit. No? This becomes 12. And then we have the partial product. We compute for the next multiplier. We load accumulator. This becomes 3. From 3, lock 3, no? Accumulator receives m of 3. And then we say sub 2. So 2 is still 1. So 3 minus 1, this becomes 2. And then we dock 3. So the next multiplier is here. Now, the critical part is here. SZA, skip on 0 accumulator. Okay? Skip on 0 accumulator. Is the accumulator 0? Everyone? No. The accumulator is not 0. So therefore, will it skip? Will it skip?
No, sir.
No, it will go to line 14. In line 14, we'll have a jump 7. So we will now proceed, go back to the top of the loop. Do you follow? So it's the same logic, but skip will only skip one line. So we'll just skip this and then we'll go to the top of the loop. This is still a bottom-up loop. Okay? Do you follow? Now, if you want this to use top-down loop, you'll use the skip on plus, no? Accumulator, SPA. Do you follow? You can do the same, right? Okay. So we'll go into a second pass, no? So in this case, in the second pass, we have the accumulator as 2, we have M1 as 12, we have M2 as 1, and this is a 2. Is this a 2? Yes. No.
Ay, sir, may question ako, sir.
Yes.
Sa pag-skip ba, like 1 lang ang makaya niya
Yes,
ma-skip or
1
pwede
lang.
tayo mag-specify?
1 lang, 1. But it's very simple, no? It's much simpler. If you're used to this, no, this is easy, no? 1 lang, because you can do anything, because you can do this inside the skip instruction. You can go to a jump where the jump will have a lot of commands. Do you follow? So for example, you need to do a lot of other things. you can jump this to an address where there's a lot of commands, okay? They follow. In fact, it has a special jump to deposit the program counter, okay? So that you can go back to where you jumped later. No, but that's a complex matter. You will discuss that somewhere in your other courses in the future. No? It's called a far call or a far jump. It's capable of a far jump or a long jump. No? Ibig sabihin ng long jump, it can jump to a very far address and then go back to where it jumped before. Do you follow? But we will not discuss that anymore. Anyway, you can, it doesn't matter whether it skips only one line or several lines. You can still convert it into a working program, okay? Do you follow? The documentation says it will skip one line, okay? Wala tayong magawa. It will really just skip one line, no? Okay. Let's read that again. If the accumulator equals 0, the program counter is advanced one extra position to the next instruction. So only one extra position. The next instruction in the sequence is skipped. Do you follow? No? One line lang talaga. Wala tayong magawa. But the designers may have decided on this because in most cases, you will only skip one line. Do you follow? Because skipping several lines will complicate the code also. They have a reason why they did it. No? Because skipping several lines will complicate the code. Okay, they want a structured approach. No? Meron na silang konting structure because you can already do a long jump. Or you can even call a subroutine. Okay, so that's why maybe they decided to use skips instead of jumps, no? Conditional jumps. But there's an unconditional jump. Okay, so that's a long story. Anyway, that's what they did, so we have to follow, no? So this is the same, no? This is the same accumulate. This is the same, no? And then we have load accumulator. So this becomes 12, and then mul M3. So this becomes 12 times 2 because M3 is it's 2. This becomes 24. And then we deposit the accumulator. This becomes 24. Okay. And then we load the accumulator again from 3. So this becomes 2. And then we sub 1. So 2. Sub 2, which is 1. No? So 2 minus 1. Because M of 2 is 1. So this becomes a 1. Do you follow? And then we deposit the accumulator. So this becomes a 1, which is our next multiplier. So we now have another skip. Okay, we will skip because the accumulator is still above, no? Above 0. We will not skip because the accumulator is not 0. So we'll jump back to 7. So we'll go back to this. And eventually we will reach 1 minus 1 and skip on 0 will work. When skip on 0 works, it jumps to 15 and this is a halt. Our answer is an M1. Okay, if you'd like to put it in AC, you can just have a duck M1 before you halt. Okay, likewise, no? Any questions so far? Now, surprisingly, no, if you look at our code, it's very simple. It's much simpler than the IAS. Why? Look at that. We don't have a left and a right in our address, right? We don't have a left and a right. Why? Because the size of data and the size of instruction are the same. Okay, so they have been proven wrong. No, this is the drawback of the drawback of the Von Neumann's design, because they have a different data size and the instruction size. So the program becomes very complicated. Here we have a linear program. We can jump to anywhere. We can skip to anywhere. We don't have a left and we don't have a right. We just move vertically. Do you follow? So it's much more logical to follow through a vertical moving program rather than the one which moves vertically and left and right also. Do you follow? So how they correct the problem? They just adapted data size and instruction size. Okay, data size and instruction size to be the same. So that solves the problem. That the programs are much easier. Do you get my point? So imagine if they started it this way, we could not have a hard time understanding the IAS program, which is very difficult to trace because of the jump left and the jump right. Do you follow? Any questions so far? So you will have an assignment. Anyway, it's a much simpler assignment, no? You just have to compute the average. No? Write a program to compute the average of the first three numbers with average, or rather with loop for the PDP1. Okay? Okay, so madali, no? Do it, submit it on Monday. So make sure this is a very easy assignment, no? You can close your eyes, no? And then write the program on paper, no? So this is write a program to compute the average of the first three numbers for the PDP1 with loop and give a trace using a worksheet, no? And save it to sheet 1. Okay, Exer 3 na ito. Do you follow? This time, no? Everyone pass by by Dagler, not by email. Okay? Any questions so far? Okay. We have 30 minutes, enough time to tell a story, okay? Let me tell you another important story. Let's look at the chronology of stored program computers. During those times, no, there were only two big manufacturers, IBM and DEC. Take note, no, when IAS was released in 1952, right after, the year after, IBM released, no, IBM 701. This is the first machine called EDP. No? So if you're asked, what does EDP mean? It means Electronic Data Processing Machine. This was first coined in 1953 when IBM invented or manufactured their first computer, IBM 701 EDP machine. No? It has 36-bit data and 18-bit instructions. So it's like a copy and paste of the IAS. The main difference is the IAS has 40-bit and 40 by 20. The IBM 701 has 36 by 18. So a slight difference. However, it still is horizontal and vertical at the same time. Diba? Because 18 bits, with 18 bits, there are two instructions that could fit in 36 bits. So it still has a left and a right. Okay? It uses fixed point arithmetic. 5-bit opcodes and 12-bit operands. No, this is strange because 5 plus 12 is only 17. So there's an extra bit. Like the IAS, it has 4 keywords. IAS pareho sila, no? But this time it uses William tubes. William tubes are smaller vacuum tube diodes, no? Because vacuum tube diodes used to be very large. The William tubes are the smaller versions, no? It uses 2 accumulators. So this is almost like the IAS, no? And this is built for scientific applications. IBM built 19 of this and have them rented for $12,000 a month. Imagine how expensive it is to rent. $12,000 a month. Yes.
Question ako, sir.
Yes.
For what tong 12-bit operands? Ito mga operands naman is like yung add, subtract?
The addresses. Because you have load M of Y, di ba? Y is 12 bits. How long can you can we compute that? How many bits can we, how many
bits?
For 12 bits? 2 to the 13 minus 1. Can you compute that? 2 to the 13 minus 1? I think it's 4096. Let's do that, no? Excel. Because we have 12 bits man, so 2 to the 13.
4096 ata?
4096.
Yes.
Yes, that's why you have 12 bits operands because you have 4096 words in memory. Do you follow? No?
Oh, okay.
Yeah, did you get my point? No? 12 bits kasi exactly that's 4096. Okay? It's easy to compute the address space. You just say 2 to the 13 because 12 plus 1, 13 minus 1, that's 4096. Exactly, no? We'll have a lesson on that, no? Binary numbers. Okay. IBM 702 by 1955, no? They made this to compete with UNIVAC because UNIVAC has tapes, no? It can access, tapes, no? UNIVAC was by Remington Rand, which bought Eckert and Mockley in 1951, no? It later became Sperry Rand because it merged with a company named Sperry. So Remington Rand became Sperry Rand when it sold computers. Okay. Anyway, you do the math, no, on the 4096. Okay. So 704 by 1955, IBM has no competitor. And you may ask, how were they able to manufacture without manufacture and sell without breaking laws, because remember, the IAS stored program concept was developed by Jan van Neumann, and if you create a machine like that, you'll be having copyright laws, violations of patent laws, right? But during that time, no, surprisingly, Jan van Neumann did not get a patent for the stored program concept. That's why IBM was able to manufacture as many as possible very quickly, no? Like every year, there's a new IBM. Okay, so 702, just a period of 2 years, there's another IBM. In 55, the same year, 704, it's like the 701, but this time it uses magnetic core memory, and we shall have a memory of up to 80K. Okay? So hindi na ito 12 bits, because 80K na instead of 4K. Maybe it's 14, no? 14 bits. No? It's the first computer that can play music. Okay? And they sold 123 units at $2 million each. So very big profit, no, without paying royalties. Wala silang binabayarang royalties eh. They can quickly build. Almost the same year, no? 705, it's like the 704, but uses 36-bit words, the same thing. No? Uses one AC because previously it has 2 accumulators. This time it uses magnetic core memory and a magnetic drum memory. It's like a hard disk. No? But they withdrew it from the market in 1964. They did not sell it. No? But the successful version came in 1958, 709, IBM 709. These are the first generation computers built on vacuum tubes. No? Single precision, so floating point na ito, it's not fixed point. It is the first computer that uses characters ABCD. Okay? Because of using the BCD code, binary coded decimal. Now our computers nowadays can manipulate characters, no? Because we have the ASCII code. And this is the first computer that uses a third programming language. It's called third level programming language called Fortran, formula translation by John Bacchus, 1956. Now by 1951, 1959, transistors became popular. IBM released the 7030, which is the transistorized version, priced initially at $13.5 million. No? Later reduced to 7.78. By then, they had a competitor because of the transistors. No? So transistors are very small and much cheaper devices than the vacuum tubes. DEC released their first computer called the PDP-1. This is the DEC PDP-1 we are trying to program, okay? 18-bit computer, 4K memory. Fixed point arithmetic. It has a CRT, the first ever computer with a CRT display. It has a typewriter keyboard, and it is the first computer to play a game called Space War. I have played this when I was in college, no? A different version, not on a DEC computer. No? It's called Space Commander by that time. Okay. The first release sold 53 units from 85,000, the low end part. I don't know how much or what the low end is. Okay, maybe different memory. To 120,000. No? It's very expensive, but very much cheaper compared to the 7.78 million by IBM. Okay, so they broke the market. The initial was 53 sold. IBM already had only had 19 on the first release. Now, 1959 transistorized na ito, no? IBM released the 790 mainframe computer. Okay, it's a bigger version which sold for 2.9 million per unit and 63,000 a month rent. PDP-2 and PDP-3 was not built, but DEC released PDP-4 on the IBM mini computer, no, 18-bit like the PDP-1. Okay, IBM released the 7094, a higher version. DEC sold 35, no, $55,000. In 1963, IBM stopped producing 7090s. They started producing, no, these are already, I think, these are IC based, no? Kasi ito transistor based pa ito. By 1965, the ICs came, no? So mini computer IC na ito, no? IC based, no? The IBM S360 is the first mainframe that runs COBOL, a common business operating language, a language used for writing database programs, and PL1. PDP-5 was released, a 12-bit ancestor of the PDP-8. They built 1,000 and sold 27,000 each dollars, no? So 27,000 times 1,000, that's 27 million. No? So DEC was breaking into the market of IBM by manufacturing smaller computers, no? Which are very useful to smaller companies and even universities, no? PDP-6, a big computer, was built for MIT because DEC was affiliated with MIT, no? For 300,000 each. PDP-7 is a popular version. It's a mini computer with real-time control, no? I don't know what real-time is, but it's still 18-bit. And then the very popular version is a DEC PDP-8. It reached the Philippines, one of Philippines, no? There are certain universities who are using PDP-8. 12-bit this time, much smaller, no? And they built 50,000 of it, and then sold them at $18,500. Imagine how much profit they got without paying royalties, no? PDP-9, 35,000, 36-bit, so bigger computer. PDP-10, 36-bit also in 1967. 1967 transistor ICs na. ICs na ito. And by 1970s came the microcomputers. Okay? 1970s. In fact, by 1976, no? Microcomputers na ito. Steve Wozniak, Apple was established, no? Steve Wozniak and Steve Jobs released the first Apple computer at lesser than $1,000. It was selling like hotcakes. Okay? And IBM, seeing a losing market, stopped the production of the S360. Instead, they switched into the IBM, the personal computer market to compete with Apple. So they succeeded anyhow, no? By 1980s, no, IBM was no longer producing large computers. It was producing the personal computer. But DEC did not produce personal computers. That's why eventually they lost in the competition. Eventually, they were bought by Compaq in 1998. And Compaq was also bought by HP in 2001. Do you follow? So that's a long story. Now, the major aspect is, how were they able to manufacture such computers without paying any royalties? What's the story about this? It's because John von Neumann did not get a patent. He did not register a patent. Why did he not register a patent? Okay, you can wiki John Vincent Atanasov, no? That's also because they were sued by a company established by Atanasov himself. It's called Honeywell. It's a defunct company nowadays, no? Honeywell was a company which produced Apple computers, Apple compatible computers, no? But it's already defunct, no? Okay, let's look at the story of the patent issues, no, of ENIAC and the store program concept. Eckert and Mockley, when they invented ENIAC, applied for a patent, no, in 1944, no, when they released ENIAC. They applied for a patent for ENIAC. And at the same time, the store program concept, even though ENIAC is not a store program computer. Do you follow? Because by 1945, they already started working with a stored program concept computer called EDVAC. Do you follow? Nagsimula na sila. But the strange thing is, by 1946, no, while they were working on EDVAC, John von Neumann published a report called the First Draft Report on EDVAC. And remember, EDVAC was owned by Eckert and Mockley. It was later found out that originally Neumann was part of the team to develop EDVAC. Okay? Eckert was working on the engineering side, no, the hardware part, and von Neumann was working on the theoretical side. Because it was von Neumann who describe in detail, okay, the working mechanism or the design of the stored program computer. The stored program concept was defined very clearly by the von Neumann report on EDVAC. But Eckert and Mockley did not contest it. They did not contest the draft report on EDVAC. Therefore, von Neumann was accepted to be or was credited to be the author of the stored program concept. So, Eckert and Mockley applied for a patent for ENIAC together with the stored program concept. Do you follow? So there was a trick there. However, no, months later, okay, they were informed by their lawyer, no, that the patent on the stored program concept cannot be given to them because of the report written by von Neumann. But von Neumann did not apply for a patent, otherwise contesting the no. Do you follow? So they got the patent for ENIAC, but the patent for the stored program concept is a little contestable, no? So the manufacturers were able to build stored program computers. However, no, when Eckert and Mockley was bought by Sperry Rand, no? Sperry Rand was sued by Honeywell. Honeywell Inc. Standing in behalf of John Atanasoff. Who's John Vincent Atanasoff? In 1936, no, John Vincent Atanasoff invented the ABC computer. Atanasoff Berry computer. Okay, they were sued because to invalidate their patent. Why? Because the patent was not original. The original idea came from the ABC computer. And what was the verdict? No, that's the verdict. It was cancelled. Okay, the patent was cancelled in 1973 because the whole story is there's the whole story. No, Mockley pala. John Mockley went to visit John Vincent Atanasoff home in Ames in Wisconsin on June 13. And then it was presented to him. The design of the Atanasoff Berry computer was presented to him by John Vincent Atanasoff and Clifford Berry. He spent 3 to 4 days there. And the operation of the ABC computer was fully demonstrated to him by Atanasoff and Berry. In fact, he was given a 35-page manuscript on the construction and operation of the ABC computer during the 3 days. After which, okay, Mockley had written letters to Atanasoff and his friends, no, having shown interest in the ABC computer, and he took a crash course in electronics because John Vincent Atanasoff was a physicist, no, and Mockley is a mathematician. So he doesn't know any electronics. He studied electronics immediately, no? Quickly. And on August 14, no? August 15, okay, Mockley wrote a memorandum between the difference between analog computers and pulse devices and incorporated some ideas that were critical to Atanasoff's 35-page manuscript. Okay. And on September 1941, before ENIAC was created, Atanasoff wrote, Mockley wrote Atanasoff suggesting that he would use the ideas to build a new computer machine. Okay. Later, it was found out that many of the designs of ENIAC were borrowed from the ABC computer. Do you follow? And that's why in 1973, a circuit judge in Wisconsin abolished or nullified the ENIAC patent, and thereby giving a free hand to the different manufacturers to create and sell, okay, manufacture and sell stored program computers freely. No? Do you follow? So there was a plagiarism during those times. It was a sad story that Eckert and Mockley created a machine without accrediting John Vincent Atanasoff, so John Vincent Atanasoff is considered to be the first inventor of the electronic machine in the US, because the first electronic machine was awarded to Conrad Zuse as the first inventor of an electronic digital computer. Do you follow? But in the US, no, the patent should have gone to John Vincent Atanasoff. So it was cancelled, no? And by that time, no, IBM and DEC, 1973 na cancel. By that time, IBM and DEC have created or manufactured a lot of machines. Okay, do you follow? No? So we'll still have a lot of history. That's the end of our story for now. We'll tell another story by next meeting. Okay, so we'll still study a lot of history. No? The first generation of computers, these are the vacuum tube diodes. No? Let's just take a look. Ito yan. Harvard Mark I is a mechanical. No? ENIAC is a first generation. IAS first generation. EDVAC first generation. UNIVAC. No? From basta 1952 to 1956, the 704 to 709, these were the first generation of IBM computers. Only IBM was producing computers during those times. No? Commercial computers. No? Okay, so the 701 to 709 are vacuum tube diodes, but the 7090 is a transistor based. No? Let's look at that. No? The 790 computer is a transistor based computer. So the first PDP-1 computer is not vacuum tube. Second generation na yan. The third generation was the generation of ICs, the 7094. No, the 360, IBM S360. The PDP-8s, I think, let's look at that. No? These are the ICs. And the fourth generation are the microprocessors, no? The Apple PCs, na? Personal computers, okay? And then we will study a lot of other histories, like the history of Microsoft Windows, the history of the computer monitor, okay, the history of the IBM PC, no, complete history of the IBM PC, okay, and then Microsoft Windows, history of the internet and the World Wide Web, okay, and then we will have a formative test. This is within the month of August. No, I will give you a practice test, okay, on this. Any questions so far? No. Okay. So we've seen the evolution, no, of the first generation of computers from Charles Babbage to ENIAC. Of course, there's a lot of Conrad Susa, no, to the ABC computer. Like Clifford and Berry, Atanasoff and Berry, and then we have ENIAC, you have EDVAC, and then you have, of course, UNIVAC, and you have IBM and the DEC. Okay, so we have done programming, and I've seen how the programs evolved, no? From the non-store program to the store program concept. The important part is the understanding of the stored program concept, because until now, no, computers are still stored program computers. Okay. So any questions so far? I will save this, and then your assignment, I will email you if we'll have class by Thursday, but most probably we will have no class, no, because students have already been asking me to cancel their classes even earlier this morning, no. But samahan, I have talked to a samahan officer. See, you see Harriet Howe, because I think he's a representative of the Samahan. I don't know who your representative is, but they have told me that Samahan has agreed, no, to have the classes canceled. Any questions so far? No. So next Monday you pass by no? You pass by a Daigler. It's a very simple exercise. You write the average of the first three numbers. We look for the PDP-1. It's a much simpler program. No? Okay, so thank you very much. No? See you next time. Guys, no? See you next time. Any questions? You can email me if you have questions. I'll look at the email. No? I have been handling classes since early this morning, so I have no time. Tomorrow I'll have the time. Okay. Thank you very much, everyone. Bye for now.
Thank you, sir.
Yes, sir.
Thank you. Bye.
Bye, sir.
Thank you, sir.
Bye for now.
Sir.
Thank you, sir.
Thank you.